So then I've got C, which is a mole to mass stoichiometry problem. It's kind of very similar to the other one. In this case, you are going to use the conversion factors of molar mass and mole ratio. So like here, I'm going to do mole ratio, and here I'm going to do molar mass substance B. Okay. Now, in this one, is actually a little different, right? So I didn't actually give you a mole to mass to mole problem here, but C is very similar to B. You're just, instead of mainly all in substance A, you're going to be, so for mass to mole, you're mainly in substance A, and for mole to mass, you're mainly in substance B. Okay. But let's look at this problem, because this problem is a little bit different, because we've got volume, we've got a density, we're looking at how many grams of aluminum do I need. So this isn't actually an example for mole to mass, but that's okay. So let's look at what we're given. So so this says, how many grams of aluminum do you need to react with 1.38 milliliters? So that's my given there, of hydrochloric acid with a density of 1.180 grams per milliliter. So it's giving me my density. Okay. My unknown, the thing that I'm looking for, is how many grams of aluminum do I need? Grams of aluminum. Okay. So this is a little bit more of a complex kind of problem here, right? And it's kind of mainly following the mass to mass stoichiometry problem. So mass to mass. So I'm going from mass of my given to moles of my given to moles of my unknown to mass of my unknown. So this is kind of the way that we're going to go about this. This one kind of takes it a step further. So like this particular problem here takes it a step further. I've got density that I need to go through first. Okay, so let's go to our roadmap here. And let's look at where I'm at. So I'm at density. I'm at volume of hydrochloric acid. I need to go through my density. So that's going to be my first line in my multiplication thing. And I've got mass of substance A. And then I'm going to go from mass of substance A to the moles of substance A using my atomic mass. I'm going to go from moles of substance A to moles of substance B using my mole ratio. And then I'm going to go from moles of substance B to my atomic mass of substance B. So through the atomic mass to get my substance B. So I have 1, 2, 3, 4 different conversion factors. So 4 different conversions that I need to make. Okay. So let's do this. So I'm going to use so I'm going to be writing this out. So I've got 1.38 milliliters of HCl. So then if I am using my density here and I'm getting out of milliliters and into grams, 1 milliliter is going to be on the bottom. 1.18 grams will be on top. So my milliliters cancel, and now I'm in grams of HCl. So times. Now I need to figure out what my molar mass of HCl is. So I've got H here and Cl here. So then I can go to my periodic table. Cl is 35.45 and hydrogen is 1.01. So I've got 1.01 plus 35.45. So I've got 36.46 grams. Okay, so then that is going on the bottom to 36.46 grams of HCl. And that is equal to 1 mole of HCl, which is on the top. Times. Now I'm going from moles of hydrochloric acid to moles of aluminum. So I need my balanced equation here. Right? So moles of hydrochloric acid is 6, aluminum is 2. So I'm going from hydrochloric acid to aluminum. So then I'm going to go 6 moles of HCl is on the bottom. and 2 moles of aluminum is on the top. Okay, again, this guy can kind of reduce down to 3, right? So then multiply. Now I need to get from moles of aluminum, so moles of aluminum, to mass of aluminum up here, right? So I know that my molar mass is equal to 1 mole, so 1 mole of aluminum is on the bottom, and then the molar mass of aluminum is on the top. So then I can go back to my periodic table. 26.98 is my grams of aluminum from the periodic table. So then this would be 26.98 grams of aluminum. Check to make sure that all your units are canceling out. So grams of HCl cancel, moles of HCl cancels, moles of aluminum canceled, and I am in grams of aluminum. Okay, so then all I have to do is calculate now. So calculator. If you look here, I've got 1.38 times, because the 1.18 is on the top, times 1.18 divided by the 36.46, because 36.46 is on the bottom. I'm hitting divided by again 3 because 3 is on the bottom, and then I'm going to multiply by 26.98. And then all I have to do is hit enter equals. Okay, so again, kind of going back here, I got 0.401666045. So then I've got 3 sig figs in my given, so that's what I want to look at. So I've got 1.38, so that's 3 sig figs there. So then I go over here and I count my numbers, 402, because the 1 is going to round up to a 2. So 0.402 is grams of aluminum is my answer. And that is stoichiometry. So then, mass to mass stoichiometry problems, your conversion factors for these, and I'm going to leave you with this one problem to do. So like if you want to get like 2 points extra credit, do this one problem, right? So I have, this is going to be atomic mass of my substance A. This is my molar ratio, and this is my atomic mass substance B. Okay. So then you can do this last problem for 2 points extra credit. The last thing that I need to kind of talk about here is this little box right here. So if I've got mass to mass stoichiometry problems, and I'm going from mass of a reactant to mass of a product. Okay, so mass of a reactant to mass of the product. These problems give the theoretical yield for the product, which is the amount of the yield that we should get out of the reaction using the mass of that particular reactant. Okay, so this is a big thing. Okay, so theoretical yield of the products, which is the amount of the product that we should form in a reaction. These are specifically for mass of a reactant to mass of a product. Okay, so there you have it. That is your intro to stoichiometry. This is learning objective 10. Perform stoichiometry calculations of 2 substances in a balanced chemical equation, or BCE.